Dear students, now we are going to see the subject linear integrated circuits. The subject code is EC3451 and the topic is IC723 general purpose voltage regulator. On the completion of this general purpose voltage regulator, students will be able to describe the operations of general purpose voltage regulator and list the drawbacks of fixed and three-terminal adjustable voltage regulator. General purpose voltage regulator overcome the drawback of fixed voltage regulator. Some of the drawbacks are do not have the short circuit problem and output voltage is not adjustable. This limitation can be overcome in IC723 general purpose voltage regulator. Features of general purpose voltage regulator. The unregulated DC supply voltage at the input is between 9.5 volt and 40 volt. The adjustable regulated output voltage is between 2 to 3 volt. The maximum load current of 150 milliamps, that is, the I max is equal to 150 milliamps. With the additional transistor used, the I max can be increased up to 10 amps. A positive or a negative supply is used to operate the general purpose voltage regulator. The internal power dissipation is of the order of 800 milliwatt. Built-in short circuit protection, very low temperature drift, high ripple rejection ratio. The functional block diagram of IC723 is shown in figure. This IC723 consists of two-stage amplifier. First stage is a voltage reference amplifier and the second stage it consists of an error amplifier. The error amplifier output drives the current limiter as well as the series pass transistor. The reference generating block, the temperature compensated Zener diode, constant current source and the voltage reference amplifier form the reference generating block. The Zener diode is used to generate a fixed reference voltage internally. Constant current source will make the Zener diode to operate at a fixed point. It is applied to the non-inverting terminal of error amplifier. The unregulated input voltage plus or minus VCC is applied to the voltage reference amplifier as well as the error amplifier. Error amplifier is a high gain differential amplifier with two inputs. The inputs are inverting and non-inverting inputs. The non-inverting terminal is connected to the internally generated reference voltage. The inverting terminal is connected to the full regulated output voltage. Series pass transistor. The Q1 is the internal series pass transistor which is driven by the error amplifier. This transistor acts as a variable resistor and regulates the output voltage. The collector of transistor Q1 is connected to the unregulated power supply. The maximum collector voltage of Q1 is limited to 36 volt. The maximum current which can be supplied by Q1 is 150 milliamps. The circuit to limit the current. The internal transistor Q2 is used for current sensing and limiting. Q2 is normally off transistor. It turns on when the load current exceeds a predetermined limit. The low voltage, low current is capable of supplying load voltage which is equal or between 2 to 7 volt. The load voltage is between 2 to 7 volt and the load current is 50 milliamps. The IC723 is a 14-pin integrated circuit. So this one is the typical circuit connection of this general purpose voltage regulator. R1 and R2 from a potential divider between V reference and ground. The voltage across R2 is connected to the non-inverting terminal of the regulator. In the integrated circuit, the non-inverting voltage is equal to R2 divided by R1 plus R2 into V reference. The gain of the internal error amplifier is large, which is equal to the input voltage. Therefore, the output is connected to the inverting terminal through R3 and R short circuit or SC and must also be equal to the voltage at the non-inverting terminal. The output voltage is equal to R2 divided by R1 plus R2 into V reference. Here R1 and R2 can be in the range of 1 to 10 kilo ohm and the R3 is given by R3 is a parallel combination of R1 and R2, that is R1 R2 divided by R1 plus R2. RSC is the current sensing resistor is connected between the capacitance, sensing capacitance and the load capacitance. The voltage drop across the sensing resistor is proportional to the load current. This resistor supplies the output voltage in the range of 2 to 7 volt. The load current can be higher than 150 milliamps. The current sourcing capacity is increased by introducing a transistor Q in the circuit. The output voltage V0 is equal to R2 divided by R1 plus R2 into V reference. So here the general purpose voltage regulator that is used as a high voltage regulator, high voltage low current regulator. This circuit is capable of supplying a regulated output voltage in the range of 7 to 37 volt with a maximum load current of 150 milliamps. The non-inverting terminal is now connected to the reference through the resistance R3. The value of R1 and R2 is adjusted in order to get a voltage of V reference at the inverting terminal at the desired output. V input is equal to reference equal to R2 divided by R1 plus R2 into V0. So V0 is equal to 1 plus R1 by R2 into Vn. The sensing resistor is connected between the sensing capacitor and load capacitor terminal as before, and it provide a short circuit current limiting of 0.6 per current limit per unit terms. The value of resistor R3 is given by R3 is a parallel combination of R1 and R2. The possible questions are the fixed in which type of regulator does 7805 IC is used. That is all the above. It can be used as a fixed output voltage regulator, current regulator and adjustable output regulator. Thank you.